In this lecture, we want to talk about in statistics what's called the FiveNumber Summary. And then also we want to talk about the visual representation of this. The visual representation of, and you'll see in a little bit of what we call the FiveNumber Summary, is what's called a box plot, or it's sometimes referred to as a box and whisker plot. Okay. So first off, let's give some definitions first before we describe exactly what is the FiveNumber Summary. All right, and we're going to go back and talk about a measure of spread or a measure of dispersion here. And the measure of spread that goes with the median. Okay, so we know that we saw that the measure of spread that went with the mean was the variance and the standard deviation. But the measure of spread that goes with the median is this thing called, or this value called the interquartile range, or I will define it as the IQR. All right, and this is really generally a better measure of spread than the range. Like if you saw, I remember in the previous lecture, the range wasn't really good because it was affected by outliers. This interquartile range is great because it's not affected by extreme values. Okay, so we're going to introduce this thing. We have to talk about these calculations called quartiles. And then we're going to relate quartiles to some interrange. Okay, so first let's start with what a quartile is. Okay, so the way you find quartiles is first you arrange the data in increasing order. We'll do this. And then next, what you're going to do is you're going to find 3 quartiles. When you think of quartiles, you know, what obviously comes to mind is quarters. So you want to divide the data up into different quarters. Okay, so the first one you're going to find is the median. Okay, so the second quartile, which we're going to denote as Q2, is the median of the data set. So the median is the value for which half the data is below and half is above. So when you think of 2 quarters, you think of 50. So that makes sense. Then what the first quartile is then, is it's the median of the bottom half of data. So it's the value for which 25% of data is below. Okay, the median is that for which 50% of data is below. And then obviously then the third quartile, then once you find the median, the third quartile is the median of the top half of data. Or another way you can think about it is 75% of data is below this value. All right, so from then we can define what's called the interquartile range, or that IQR. And it's just the difference, so the IQR is just the difference between the third quartile and the first quartile. So it's Q3 minus Q1. So what it really is, it's the range of the middle 50% of data. Okay, that's what this IQR is. It's the range of that middle 50% of data. Okay, so how you do this, all right, you're going to first arrange the data in increasing orders. You're always going to find Q2 first, and then I'm going to show you by hand how you find Q1 and then Q3. And then you can summarize this result in what we call a 5-number summary of a data set. And a 5-number summary shows that first quartile, second quartile, and third quartile that you found. And then it also shows the min and the max of this. From this 5-number summary, the visual representation of this is called a box plot. Okay. So I'm going to show you now how to find these by hand and then how you sketch the box plot for this. Okay, so suppose you have this data set here. It says find the median in the quartiles for the data below. So you're going to take this data set here. Okay, it's just a bunch of numbers, 12, 6, 4, 9, 8, 4, 9, 8, 5, 9, 8, 10. And you're just going to order the data. Okay, and when you do, you order it this way. So the first thing you're going to do is you're going to find the median for this data set. All right, and it turns out that the median falls between these two numbers, 8 and 8. So the average is 8. That's the second quartile. Then to find the first quartile, you're just going to look at this right here. So Q1 is the median of this set of data. And when you do that, you can see, boom, the first quartile falls between 5 and 6, and it's 5.5 or 5.5. Then the third quartile is just going to be the quartile for this. So it's the median of the top half. And you can see that there, the median falls right there between 9 and 9. From this, you can then calculate the interquartile range of the data. And that's the spread, the range from here to here. It's the spread or the dispersion of the middle 50% of data. And that interquartile range is just 9 minus 5.5, which gets you 3.5. Okay, now what we want to do is we want to draw the box plot of this. Okay, so this is the visual representation of the FiveNumber summary. Okay, the visual representation of that FiveNumber summary. So remember what that was, okay? It was the min value, quartile 1, quartile 2, quartile 3, and the max value. All right, so we've got those, the first quartile, the second quartile, and the third quartile. So what you do is you draw a number line, okay, that's going to go from 4 to 12 here. And what you do is you draw a box. The first part of the box represents the lower quartile right here. The upper part of the box represents the upper quartile, 9. And then within the box, you're going to put a line for the median right there. Okay? The range of this box, by the way, is the length of the, or is the interquartile range. So the length of this box is the interquartile range. Then what you're going to do is you're going to draw a whisker out to the minimum value, and then you're going to draw another whisker out to the maximum value. So what you're seeing here is you get the minimum value, quartile 1, quartile 2, quartile 3 of the data set, and the max value of the data set right there. Okay, let's just do another one quick, a little bit different. So let's find the median and quartiles for this data set below. So you're going to order the data here. Now when you go to find the median of this data set, you're going to see that it's that letter 8. So if you're going to do this by hand, you're going to find the median of just these values here. So quartile 1 is median here. So when you look there, you can very obviously see then that quartile 1 is 4. And then when you go here, you're going to find the median of the top half of data. And you can obviously see real quickly that that's just the number 10 right there. So you can find then the spread here, the range of the middle 50% of data. That's just your interquartile range, which is Q3 minus Q1, which is 6. And now we can do the box plot for this. So again, set up your number line from 3 to 15. Draw the box from the first quartile to the third quartile. Then embedded in here, you're going to put the median, and then a whisker down to the minimum value and a whisker up to the maximum value. And you can see here that I've got the minimum, quartile 1, quartile 2, quartile 3, and the max value here in my data set. Very, very easily. All right, so what are some uses of this? It's really good for comparing 2 or more data sets. Like if you want to look at the heights between boys and girls in middle school, you can see that boys are just generally taller than girls. You're seeing that here. And then also if you want to compare, weather in cities, you can compare the weather in Seattle, San Antonio, and New York. And a box plot here just shows, the variation in the weathers between the cities. It's very useful. All right, also you can see a box plot can tell you if a data set is skewed or not. So if you have a whisker that shoots off to the right in your box plot here, you can tell that it's right skewed. If you have a whisker that shoots off to the left, it's generally left skewed. And if it looks very symmetric, your data set's probably a bell curve here. All right, so now I want to talk about outliers, okay, in a data set. And specifically, eventually, I want to talk about how you find outliers. and how you show them on a box plot. Okay, and I'm also going to show you how to use your calculator here. Okay, which will be very, very useful. Okay, so an outlier is an unusual score relative to the data set, okay, and we know that it influences the mean and standard deviation, and this is important. You can be an outlier by being a low value, or you can be an outlier by being a high value. So you can be an outlier on either direction, top or bottom. So a data set can have no outliers, one outlier, or several outliers. And what you have to do to find outliers is you have to use these things called the lower and upper limits, or I also call them the lower cutoff value or the upper cutoff value. Okay, lower or upper cutoff. And so there's just a formula for this, and there's no rhyme or reason. These formulas, there's no theory base behind them. These are just formulas that statisticians have agreed to over time to figure out what the lower and upper cutoff values are. So the lower cutoff value is Q1 minus 1.5 times this IQR, and the upper limit or upper cutoff is Q3 plus 1.5 times the IQR. And you're going to use these values, these lower and upper limits or lower and upper cutoffs, to identify and see if there's an outlier within a data set. All right, let's do this example here. All right, I'm going to do this by hand and show you how to use your calculator for this. So what I want to do is I want to construct a box plot from this data set of TV viewing times. So just imagine this is a sample of 20, it looks like 20 data values, and it asks, hey, how many minutes of television did you watch last night? Okay, so looking at this box plot here, or this set of data, you can see that there's a low value of 5 and a high value of 66. Okay, so maybe this 66 compared to it is an outlier, and maybe this 5 is an outlier. We don't know. We have to test for that. Okay, so the first thing we're going to do is let's find the quartiles for this data set. And what I'm going to show you here is how to use your graphing calculator to do this. Okay? So we're going to take this graphing calculator here, and we're going to take this data and we're going to plug it in. So to do this, to plug data into your calculator, you're going to hit the stat button right here. And under number 1, you're going to edit the list. So you're going to hit enter. And what you're going to do is you're going to take all these data values and plug it into your calculator. So you're going to hit 25, 66, 34, 30, 41, 35, and you're going to keep going. 26, 38, 27, 31, 32, 30. Keep going. 32, 15, 38, 20, 43, 5, 16, and 21. All right, so now instead of doing it by hand, finding the quartiles, I'm going to have my graphing calculator do this for me real quickly. So what I'm going to next do is I'm going to hit the stat button. And under number 1, I'm going to edit the list. Or excuse me, I already edited the list. I'm going to scroll over. Sorry about that. I'm going to go to calc, and I want this thing called 1-var stats. So I'm going to hit enter. And then I'm going to see it, so that list 1 where I had my data. I'm going to scroll down to calculate. Now, if you have a TI-83, it's just going to say 1-var stats. Just hit enter again. And I'm going to hit enter here. Wow, look at this. If I scroll down here, I see Q1 is 23. The median, which is Q2, is 30.5. And Q3 is 36.5. Awesome. So using my graphing calculator, I saw quartile 1 here really quickly was 23. Quartile 2 here was 30.5, and quartile 3 was 36.5. Great. Now let's find the IQR, the interquartile range. Well, that's Q3 minus Q1, which is 36.5 minus 23, which gets me 13.5. Now, for a box plot, are there any outliers? Okay, because how you show an outlier on a box plot is very, very important and very different. Okay, so you need a lower cutoff or a lower limit. And just use your formula here. It's Q1 minus 1.5 times the IQR. So this is 23 minus this IQR, or 1.5 times this IQR that we found here. And I believe, let's check our calculator for this. You're just going to go 23 minus 1.5 times that IQR, which was 13.5, which is 2.75. All right, so what you're seeing here, and this is what you use for the lower limit, any value lower than this number is an outlier. So look at this. Is this 5 lower than 2.75? No. So there is no low outlier. But let's check the upper limit. Okay, so that's Q3 plus 1.5 times the IQR. Okay, well that's 36.5 plus 1.5 times that IQR of 13.5. Well, again, let's grab our trusty calculator. So 36.5 plus 1.5 times this 13.5 is 56.75. So what that means is you look back at your data set and you say, is there any value in this data set above 56.75? Yes, yes. So 66 is an upper outlier. All right, so now what we want to do is now we want to sketch the box plot with the outlier. All right, so to do this by hand, what you're going to do is you're going to draw a number line, okay? And it's got to be able to catch the lowest value to the highest value. So what I'm going to do is I'm going to start at 0, and I'm going to go by tens. So 10, 20, 30, 40, 50, here's 60. I'm going to go a little bit further, and here's 70. Okay, so let's start with how we would do it before. Go to the number 23, and then you're going to draw a box out to 36.5. So I'm going to eyeball it roughly here, okay? So here's Q1, here's Q3. Now where the median is, 30.5, you're going to draw another one. That's Q2. Okay, so we knew 5 was not an outlier. So I'm going to draw a whisker down to the number 5 here. All right, now how you show the outlier, because this is an extreme or unusual value, you're going to go to 66, and you're going to put a little asterisk. Okay, so there's your outlier, the number 66. So then what you're going to do is you're going to look in the data set, and you're going to find the next highest value that's not an outlier, which is 43. And what you're going to do is you're going to draw your whisker out to 43. So what this shows is it shows now the min value, quartile 1, quartile 2, quartile 3, the max value that is not an outlier, and then the outlier. So this whole problem here was how you identified outliers and then sketched it in the box plot. Okay? All right, let's do this example here, okay? Let's look at the ages of actresses at the first time they won their Oscar. Okay, so it looks like I have a ton of data here. And what I want to do is I want to use this data set to find if there's any outliers, okay? So look at some of these values here. It looks like there's somebody who won an Oscar when they were 21 years old. That's awesome. And then look, there's somebody who won an Oscar, I think, when they're 80 years old. Okay, and there's some other crazy values in here, like 74 is in here. I don't know, 24 is pretty young too. I don't know. So here's what I want to do for this data set here. All right. I'm going to give you the 5-number summary, and I want to see if there's any outliers in this data set. Okay. I'll actually do the work here. So recall, to find outliers, you need the cutoff values. All right. Since I give you these values here, the first thing you're going to have to find is the interquartile range, which is Q3 minus Q1, okay, which is 41 minus 30, which gets you 11. Now the lower cutoff, or the lower limit, you're going to take Q1 minus 1.5 times the IQR. In this case, because I give you Q1, this is 30 minus 1.5 times 11. Let's grab our trusty calculator here. And you get minus 13.5. Oh, sorry, a little bit of a, it's 30, sorry, minus 1.5 times that IQR, which is 11, which is 13.5. Forgive me there. Okay, so that means any value below 13.5 is an outlier. Well, if you look back here, there's no age younger than that, so there's no lower outlier. So let's find the upper cutoff. So this is Q3 plus 1.5 times your IQR. Well, this is 41 plus 1.5 times that IQR of 11. So 41 plus 1.5 times 11 gets me 57.5. So what that means is any value above 57.5 is an outlier. So this data set actually has multiple outliers. 80 is an outlier, 61 is an outlier because that's above it, 74 is an outlier, 61, 60 is an outlier. Wow, there's a lot of outliers in this data set. And this data set is 1, 2, 3, 4, 5 outliers. All right, and that's good. That's okay. You can have more than a single outlier in a data set. All right, what I want to do now, just to end this lecture, is I want to go back and I want to show you how you can get this box plot that we did in this example here in your graphing calculator. Okay? So what you're going to do this is we're going to use what's called stat plot. All right, and we're going to use stat plot a lot in the coming weeks. So I'm going to, after you have stat and you've inputted your data in here, your calculator produces a lot of statistical plots for you. So I'm going to hit second function stat plot. And what you're going to notice with your calculator is it's going to say plot 1 ... off. So I'm going to hit enter, and I want to turn it on here, right like this. So now that it's on. And here are all these different plots here. So I want to scroll down and look here. This looks like a box plot with those dots with those outliers. So I'm going to go over and highlight this. The next thing you would normally do when you wanted to plot something with your calculator, a graph, you would hit graph. And what you'll notice is when you hit graph is it looks like this. Well, that's because your graph is zoomed into the center of the Cartesian plane. But if you hit this zoom button on your calculator, zoom here, and you scroll down or look for number 9, you see this thing called zoom stat. And this will zoom your graphing calculator around that plot that you have. So I'm going to press enter. And wow, look at this. This box plot looks almost identical to what we have here. So we'll keep doing plots like this in the coming weeks with our calculator, and we'll get more practice with it. All right, thanks, class.